Hello everyone, good morning, good afternoon and good evening to all. Dear authors and invited guests, welcome to the technical session 4A. I am Anisha Mishra, the moderator of this session on behalf of Global Knowledge Research Foundation. It is my great pleasure to welcome you all to the 6th World Conference on Smart Trends in System Security and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive sessions through the day. Just before we get started, I would like to introduce you all to the chair of this session, Professor Alexander Reiker. He is the Doctor of Technical Sciences, State Advisor of the Russian Federation, and winner of the Russian Government Award in the field of Science and Technology. He is a full member of the Russian Academy of Natural Sciences, full member of the Academy of Forecasting Russian branch of the International Academy for Future Research, full member of the International Academy of Sciences of Information, Information Processes, and Information Technologies, full member of the International Academy of Informatization. He is a professor of the MIREA Russian Technology University, leader researcher of the Institute of Control Sciences of Russian Academy of Sciences. He is the head of Artificial Intelligence Department of the National Center of Digital Economy of the Lomonosov Moscow State University, Director of the Center for Artificial Intelligence of the International Research Institute of Management Problems. He is a scientific leader of the Expert and Analytical Center of the Institute of Tax Management and Real Estate Economics of the Higher School Economics. Welcome to the session, sir.
Welcome. Let's begin.
Yes,
begin.
Okay, sir.
Okay. Let's listen.
So now we'll start with the papers.
Okay,
so there's a special note for all the presenters. You will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I'll raise a gentle reminder. If you have any update or query, you can write it to me in the chat box. And there's another request to all the participants that you please stay connected with us till the closing of the session. Okay, so now we'll start with the papers. So our first presenter is Jamaya Yahaya, and the paper title is Green Software Product, the Empirical Study on Social Factor and Measurements. Dear presenter, you may please start your presentation.
Okay, thank you. I will share my screen. Okay, is it okay?
Yes, you're visible.
Let's begin.
I already share my PowerPoint. Thank you very much. And hi, everyone. Good morning to all the participants here who are in the west of the globe. And good afternoon and good evening for those who are at the east. So today I would like to present my paper entitled Green Software Products, the Empirical Study on Social Factors and Measurements. My name is Jamaya Yahaya. I'm from University Kebangsaan Malaysia. The outline for my presentation today started with the introduction and background study, and then I move on to social sustainability in software products and data collection analysis, the relationships of measurement, and I conclude with the conclusions. So as the introductions, the use of software in this modern technological world has enormously affected the environment and the social sustainability. Literature studies and experts have discovered that significant effort have been made to measure and organize the level of greenness within the ICT hardware, but still the inadequate attempt have embarked on sustainability being green software product or green also in terms of green software process. Recently, producing information technology product with eco-friendly green software has become the aim of the hardware and the software industries. The environment aspects of sustainability were discovered the most, especially in the literature. So social sustainability implies maintaining social capital among societal groups and saving the unity and harmony within the society. Social capital is essential to make up society fundamental structure. Social sustainability can be defined as maintaining social investment and assisting social groups in their associations in harmonized society. It meets the essential structure of society and is believed to reduce transaction expenditure and cost. Previous study revealed that little effort in research was carried out on the social sustainability within the software products and also in the software process as well. Scholars agree that the earlier work did not include comprehensive dimension of sustainability, which are three fundamental dimensions: environment, economy, and socials. In the current dynamic environment among society and people, exploring the social sustainable dimension in the software products that impact the community is significant since most people use the software in their every aspects of their life. So what is sustainable software? So sustainable software is a software that has an indirect or direct impact on the society, human being, environment, and the economy, either from the development or the use of the software, whereby it has a lower negative or potential positive impact on the sustainable environment. Tool and employee supports are the primary measurements of social sustainability in the software aspects. From literature, we discovered these two main measurements. Yeah, so tool support and employee supports. So previous studies investigated the social perspective of a software product by introducing a social compliant design, accountability design for the ability to maintain social sustainability through societal intervention and innovation. Each of the measurements is directly associated with the subjects of tool support and employee support. And furthermore, social sustainability implies maintaining social capital and protecting the social groups in their completeness. Also, a positive and long-haul condition inside group and a procedure inside group that can accomplish and keep up the condition. And like I mentioned earlier, that the two fundamental or two essentials measurement in social sustainability is to support and employee support. The two support means that a supporting tool in the development process that meet user needs in producing suitable software product. And for the employee support means that offering and assisting employees in the organizations to utilize new tools in excellent software development activity. Furthermore, in social sustainability for software products, keeping employees happy, happy, joyous, and fruitful in crucial. Fruitful is crucial because the characteristics have been recognized as the most effective approach to maintaining a productive environments in the organization. In this scenario, the dream members are self-organized, famous among other employees, and interoperable with other staff and friends. They bring together to train and educate dynamic, energetic, and robust employees through sustainability. So since green has become a more common and standard, a growing numbers of employees prefer to work for companies committed to sustainability and try to find a work conditions where working green practice value are implemented. So similarly, employee function of organization can foster a thorough approach to supervision culture and sustainable environment. And for this research, we have done an empirical study in Malaysia, and I present the data collection and analysis in the next few slides. So the list of inquired possible software companies from private and public sectors in Malaysia was identified and contacted for the invited as a potential respondents. The total sample was 220 respondents, but only 148 respondents agree. And a total of 102 were found as a valid data. Most respondents preferred to answer the questionnaire by email rather than face-to-face meeting during the COVID outbreak. During that time, during the data was collected, was COVID-19 outbreak. Thus, the online questionnaire was constructed and carried out in this study. The criteria used for agency selection of this study are software development companies or the company and the agency that acquire and use software in their primary operations. The respondents are in the group of software developer, administrator, IT practitioner, and software user. So as the results of the analysis, as one of the primary measurements that like mentioned earlier in the background, employee support obtained the most important consideration and rating by employees respondent. Employees support is considered a solid matter as every employee can become the champion in achieving the green target in software products. Besides, employee engagement was one of the top secrets to the successful and effective social sustainability in the organizations. Similarly, the tool support also is crucial in social sustainability, mainly supporting software development activities. The company's ability to use a chosen collection of tools is vital to automating software development in the industry. The practices regarding tool support as a social sustainability measurement in software product are justified as a significant considerations. So during in this study, we have collected the data and we compute the mean of the data to come up with the average score for each of the measurements, to support and employee support. And we have discovered that the mean average for this data 4.37 for to support and 4.38 for the employee support. And when we map this into this degree of importance, it falls under the most importance. 4.8 falls under most important, as you can see in the left hand side of the table. The left side of the table on your screen. And then at the same time, we also do relationships of the measurement. The relationship of the measurements, then the data discover that the social sustainability has positively connected to the employee support with the R value 0.685, and similarly, the social sustainability also has positively connected to support with the number of 0.662 of the R value. Thus, is stated that the relationship is recognized and accepted. And now this slide shows the overall structure of the green software elements and measurements. As you can see here, there are three main elements of sustainability and green. Green and sustainability are very interrelated. To obtain green, we need to ensure that it's sustainable in the environment. So there are three important elements from literature: the social, economic, and environmental. But for my presentation and for my paper that I published on this conference, is only discussed about social aspects, social element of green software products. And you can see here, the social can be broken down into a measurement of employee support and tool support. And furthermore, the measurement also will be broken down further into sub-measurements. And then from there, we can produce direct assessment metric, which is more quantifiable for the assessment. Then similarly for the economy and also for the environmental. So for this slide, I just show you the comprehensive structure of the green software elements and measurements. And then the next slide here explains about the measurement in more detail, where I have mentioned just now that the measurement, the social element can be broken down into measurements to support and the employee support. And for the measurement,
dear presenter, sorry to interrupt. You have last 1 minute.
Okay. For the measurement can be broken down into sub-measurement and metric, where the metric are more quantifiable for the further assessment. Okay, so as a conclusions, this paper has been presented the recent literature concerning social factors and measurement about attaining green software products. Based on sustainability perspective, we focus on social factors and measures related to green software products. Two main measures of social factors were determined from the literature, which employee support and tool support. Then empirical study, which was conducted by our research group, has investigate and validate the proposed measurements. So the findings reveal strong relationship between the social factors and the measures that we discussed in this presentation. So the results are also consistent with the findings from literature as discussed in this paper. So thank you very much. That's all for my presentation. This work is also supported by the Malaysia Ministry of Higher Education Fund under the Fundamental Research Grants Scheme. Thank you very much for your attention.
Okay. We don't have time. Yes, but I'd like to ask you small questions. You are talking about social sustainability and software. And have you heard anything about social responsibility of IT business? Social responsibility. Have you heard? It's very interesting direction which connected with social sustainability.
If I can answer your question, the social responsibility is the one that you mentioned, right? The social responsibility is not covered in the scope of this project. This project is about achieving green software products based on social.
Okay, I understood.
elements.
Thank you. You have got that. Okay.
But yeah, but it's a good comment. Yeah, okay. Thank you for the comment. Okay, thank you. Yeah.
Okay, thank you for your great presentation.
Thank you.
Now we'll move on to our next presenter, Yuhan Lee, and the paper title is Posture Control of Collaborative Robotic Manipulator Based on Gesture Sensors. Dear presenter, you may please start your presentation.
Okay, can you hear me?
Yes, I can hear you.
Can you see my screen share?
Yes, it's visible.
Okay. Hello, everyone. I'm Yuhan Li, working in EU Industrial and Commercial College in China. My research interests include robot control and computer vision. Today, I'll make a presentation on behalf of my research group. The theme is about control of collaborative robotic manipulator. And the title is Posture Control of Collaborative Robotic Manipulator Based on Gesture Sensor. Well, next, I will introduce it from the following aspects: a brief introduction of the background, system framework, control measure of the manipulator, testing result, and finally, conclusions. The motivation of the research is because more and more attention has been paid to the safety problem in the process of cooperation between human and robotic manipulator, especially in many industry scenes. In order to ensure the safety, it is necessary to keep a safe distance between operator and robotic manipulators. So it is necessary to choose the appropriate method of human-machine interaction. Gesture control is one of the more used methods. And the existing research on gesture control for robotic manipulator mainly focus on controlling the movement of robotic manipulator in X, Y, Z direction in Cartesian coordinate system and controlling the action of an effector. But there are few studies of posture control of the robotic manipulator, including X, Y, Z, roll, pitch, yaw, in Cartesian coordinate system. The design system consists of the following devices: lip motion gesture sensor, 6-joint collaborative robotic manipulator, X-arm, and a PC. PC sends control signal to launch lip motion and get its feedback signal. The posture of X-arm is controlled by the signal. Lip motion is a gesture detection sensor module produced by Ultraleap company, which can capture the user's palm and finger movement for interaction with digital content. The sensor can check the movement of the hand in a three-dimensional space of 60 centimeter or more. And it can identify 27 different hand elements, include bones and joints. And its typical working frequency is 120 Hertz. The control object is X-arm. The arm span of these manipulators is 700 millimeter. The repetitive positioning accuracy is 0.1 millimeter, and the maximum speed is 1 meter per second. The palm posture and X-arm posture are uniquely determined by 6 parameters: X, Y, Z, roll, pitch, yaw. However, the reference coordinate system is different. To control the posture of X-arm, it is necessary to convert the palm posture detected by lip motion into the posture of X-arm to center point. Lip motion's origin is defined here as OL, and define the current palm position detected by lip motion as the coordinate origin under the new coordinate system, which is expressed as the direction or expressed as OH. For X-arm, the origin of its base coordinate is OB, and the two coordinate system is obtained after the base coordinate system rotate 180 degrees around its x-axis. When the end effector is not installed, the origin of the two coordinate system is the center point of the flange. And define the origin of the two coordinate system as OE. And suppose a point OH prime in coordinate system of lip motion, which is transformed into a point OE prime in X-arm 2 coordinate system. The position and posture of OE prime can be obtained by the formulas. Use the platform shown in the figure to test and calculate the position checking error and the delay time response of the position checking in each step of the test. For the convenience of the judgment, calculate the Euclidean distance with the position checking error by formula 6. In order to make the collaborative robotic manipulator respond to the gesture signal detected by lip motion in real time, the X-arm controller is set to join servo mode. In this mode, the maximum receiving frequency of the controller is 250 Hz, and X-arm will move to the position point with the fastest speed and acceleration. However, the typical working frequency of lip motion is 120 Hz. During the operation, X-arm has reached the target point, but lip motion has not sent a new posture signal. At this time, the pose information obtained by X-arm from lip motion sensor is still the posture of the previous target point. So the posture information will be repeated. That is, invalid posture information will appear. Here is the program flow. When the program runs, first initialize the TCP point of X-arm, that is OE of the two coordinate system, and set X-arm's motion mode to 1, then start lip motion to monitor gesture. When the palm enter lip motion detection area, set the current palm position to OH. We can see in the formula 5, we use formula 5 to calculate the results and control X-arm to move to target position. In order to avoid duplicate data and make X-arm check the gesture data detected by lip motion effectively, a constraint condition is designed. The X-arm motion instruction can only be executed when the target posture is different from the previous posture. According to the testing results, under the parameter of different speed and acceleration, most tracking error are less than 10 millimeter, and the average error is about 3 millimeter. And quite a few points can achieve error-free tracking. Okay, we can see the control result through the video. And you start the X-arm and the program can control the collaborative robotic manipulator. Like this, it's real-time control. Okay. In the control process, the observed trajectory of exam looks smooth, but in fact, there is noise in the data. For example, if the operator wants to control exam to stay steadily in a certain position, the pump also needs to remain stationary. However, due to human physiological characteristic, that there are still small jitter when the pump is still, such as hand shaking. So exam also check this jitter and make small movements. In order to reduce noise, the min filter is used to filter the data. Use the method to filter the data of the above tests. It can be seen from the data in the figure that the curve composed of the raw data is jagged. That is, the movement of exam is not smooth. Although the amplitude of this jitter is relatively small, after min filtering, the trajectory of exam becomes smoother. The experiment results show that the checking error of this method is within an acceptable range, and its checking response speed can meet the real-time requirement. The technique proposed above can be applied to scenes that are not suitable for people to carry out on-site operation, such as assembly work in harsh working environment like high temperature. The use of gesture control can protect people from injury to the greatest extent. However, the min filter will reduce the real-time performance to a certain extent. This problem needs to be overcome by design better filters. On the other hand, the research of this paper is based on a manipulator without N2. In the actual scenes, the manipulator often needs to install an effector to perform specific tasks. Therefore, the follow-up research will carry out for the manipulator with an effect, such as gripper or dextral arms, like this one, dextral arm installed in X arm. And so thank you very much for your attention. If you have any further question or want to know more information, please contact us through the email. And that's all of my presentation. Thank you.
Okay. I will ask you one question if you don't know.
Okay.
Tell me, please, have you heard anything about using, in your case, the quantum algorithm? Some of my friends use the quantum algorithm, and they tell me that it works more careful and in detection of quantum algorithm. Have you heard about this?
Do you mean why I use lip motion to control the collaborative robotic arm?
Body.
It is an untouched. Yeah.
It's another direction in recognition of the motion. Okay, this is. Thank you. I think that very interesting results. Okay.
I use lip motion because it is small in size and it can control the arm, not touch anything, just move your hand.
Okay. Okay. You just move your hand. Okay, I understood.
Yes, just for the convenience.
Okay, I understood. Thank you very much, Anisha.
Okay, thank you.
Okay.
Thank you very much. Very interesting. And I want to ask you, have you a plan for the future to implement it in real practice?
Okay, thank you for your advice.
Yes. have you got a practical application in real practice? Do you use this system? No, Anisha, let's the next. Well, thank you very much.
Thank you for your great presentation. So now we'll move on to our next paper. And the paper presenter name is Ivan Nedialkov, and the paper title is Methodology for Studying the Generated Communication Traffic from Power Electronic Devices. Dear presenter, you may please start your presentation.
Hello, my name is Ivan Nedialkov, and now I'm going to present our work, Methodology for Studying the Generated Communication Traffic from Power Electronic Device. In these days, the power electronic device are capable to be connected to all kinds of communication networks, especially now for the IP network, because the IP network is the hegemon in the communication network. So when they are connected to the IP network, additional studies must be carried out to find out what kind of communication traffic they generate. Is it the exchanged information between the power electronic device and the command sender is secure? What is the most used protocol? What is the amount of generated traffic, and so on? And this information will help to design the best IP network for this device, or it will be find out if this device can be connected, let's say, to a data network of a cellular operator. For this reason, we propose a very simple and easy to implement methodology for characterization the generated communication traffic from a power electronic device. These are the 5 stages of our methodology. The first stage is choice of monitoring technology. There are 2 types of monitoring technology. This is the passive monitoring technology and the active methodology. In the passive methodology, there is, let's say, a listening device somewhere in the network, which is used to listen and capture all the traffic that is exchanged in the network. Then this traffic, after the monitoring is over, the traffic is analyzed and some measures are taken. The traffic is not changed; it's only collected. In the active measurements methodology, there must be several devices put in the network who will be used to inject additional traffic, the so-called beacons. These are measurement packets that are used to measure the traffic, and then the information is sent to a server. And again, after the measurement, the data will be analyzed. For our work and for our study, it is chosen to use the passive methodology because it is simple to implement. The power electronic devices don't generate huge amounts of traffic, and because of that. The second stage is after we choose the methodology, it will be the passive or the active. In our case, we use the passive methodology for monitoring. It must be we must create the experimental IP network to which the power electronic device will be connected to the workstation. I'm sorry for the poor quality of the graphics. In the paper, they look much better. Again, there are several types of experimental network. You can the simplest one is directly to connect the studied power electronic device to the workstation and to monitor the generated traffic. If there are several power electronic devices, which must work simultaneously, like PV solar controller or an inverter or a PV battery charger, and they must be monitored from distance. Then for the experimental network, we must use the switch or a hub, and of course, if we use a switch, it must be managed because we need to use the so-called mirroring port. All the traffic that the switch is computing must be sent to this mirroring port, and the workstation must be connected to this mirroring port. And of course, there is a third option when you don't have the acquired network equipment, or you don't have enough financial to buy this equipment. You can use software platforms for modeling of IP network, as we used in our work. This is a simple topology of such a model of network. This is our workstation. This is the tested device. There are several network devices which are used to transfer the communication traffic. The next stage is when we choose the monitoring technology. We created the experimental network. We will be physical, or model one is the actual monitoring. For this monitoring, there is good to use several monitoring tools. Like in our work, we use a network protocol analyzer, Wireshark, network analyzer, like Capsum. Free with the network analyzer, you can see the amount of traffic that is generated from this power electronic device, which protocol is most used, which port is most used. And with Wireshark, when the packets are captured, we can do additional studies. The next stage is studying the security of the data exchange. This stage is optional. If you don't, this kind of information don't interest you, you can skip this stage. But in this stage, you can see if the information, the data exchange is secured. As can be seen, this is a print screen from the Wireshark. It can be seen if there is a notification, is it secure or not? And this is one of the many features of the Wireshark. The last stage of our methodologies analyze the results and recommendation for choosing the best communication network. Based on the results, we can choose the best IP network for our power electronic device. It can be an Ethernet network, or based on the results, it will be possible to use the data network of a cellular operator. In our study, we use the model platform for modeling network. This is our topology of our network. This is our workstation and the power electronic device, because we don't have the managed switches and routers, and because of that we use the platform for modeling of IP network. The platform is GNS3. These are some of the results. Here is the generated traffic from the power electronic device. The tested power electronic device is power distribution unit. It is used to distance operate, turn off, turn on devices.
Dear presenters, sorry to interruption. Your last 2 minutes.
12 minutes are over. Okay. And these are other results. We use the Wireshark and see that the the exchanged information is not secured. It's sent in plain text. In conclusion, we present a methodology for studying the generated communication traffic from power electronic device. The offered methodology is simple and easy to fulfill. Based on the results of the research, according to the proposed methodology and analysis, the most appropriate communication network to which it can be connected can be determined. For our tested device, it can be connected to any IP network because the traffic it generates, it's very low and cannot affect the performance of the IP network. And thanks for your attention.
Okay, thank you very much. I'd like to ask you one question or two questions. You have to collect a lot of data and then analyze this data, as I understood. But as usually the scientists or engineers are using artificial intelligence technology, deep learning and big data analysis methods. Do you use such instruments for analyzing and forecasting of the work of your system?
No, we're not using any of this technology. We use the
Artificial intelligence, big data analysis with the deep learning systems. Do you use this technology?
Yes, but in our research we are studying one power electronic device and not like a network of several hundred of several hundreds of power electronic devices. This is only one, and we don't implement such technology. Maybe if we can access such a network, but for now we don't have an access to such a network, then yes, there will be more easy to use this kind of technology, but for now we are not using this kind of technology.
Because I remember that many years ago, 30 years ago, we had used artificial intelligence for raising the effectiveness of network communication. And now we are using this technology for making the results of the quality of network communication better. Thank you very much.
Thank you.
But it's very interesting. Very interesting. Thank you. It's a good systematization. But I think that in future you may think about using modern systems of analysis and collection of data.
It's a good proposal.
Okay, that is perfect. Thank you very much.
Thank you.
Okay.
Thank you for your great presentation.
Yes.
So now we'll move further to our next paper. And the presenter name is Michel Picariello, and the paper title is Disruptive Technologies, the Spread of E-Government in the European Union and its Bottlenecks. Dear presenter, you may please start your presentation.
Let's listen about disruptive. Disruptive. Thank you.
Good morning, good afternoon, or good evening for all. I'm ready to share. You see it? You see the presentation, please?
Yes, we can see it. You may continue.
Okay, no problem. Hello, I'm Michele Picariello, Research Assistant for the Università degli Studi della Campania, Luigi Vanvitelli. And today I'm going to talking about disruptive technologies, the spread of e-government in the European and its bottlenecks. So, full Professor Alfonso Marino and PhD Paolo Pariso are collaborating with the stagiaire of the paper. So, the purpose of our research is theoretically and empirically to explore how public e-government spread in EU. The ranking between European countries has taken into account the following indicators: ICT usage, digital public services, connectivity, online services index, telecommunication infrastructure index, digital skills, and Gini coefficient. The comparative study showed that the problem of the digital divide, despite investment in infrastructure and the possibility of accessing this information, is still present. So the implementation of a digital process through information technologies, or ICT, has its fundamental aim the improvement of effectiveness and efficiency. In government, amplify the perception of transparency and increase the previous aspect, arriving to ferry the entire concept of e-government in e-government. A disruptive phenomenon that has been accelerated by the pandemic COVID-19, whose appearance put a strain on the ability of adaptation and reaction by governments. For the EU, e-government is one of the key pillars of economic development. In this figure, we show the process of implementing digital government transformation and highlights the key pillars of a strategy and implementation plan. This can be used as a capacity development tool to identify the elements and steps needed to move the digital government transformation process forward. So we have ICT and e-government as a central core related to citizen, business, no-profit area, and central government. Understanding e-government and the value it should require a deep understanding of public sector administration, and the citizen, therefore, is the protagonist of this revolution and is an active part of the creation of value and health within the digitalization processes. Thus, ICT technology could be the perfect vehicle for creating public value. A disruptive shift within the public sector, technology must also support this impact. Therefore, it will be necessary to reason in symbiosis with the use of such technologies when planning governmental strategy or political reforms for the technological or cultural updating of the public sector. To do these activities are, of course, need to be planned. Summarizing all these 12K recommendations organized in 3 pillars: openness and engagement, governance and coordination, capacities to support implementation. These 3 pillars are the core for creating public value through the use of ICT. At this point, we have some questions, and we ask ourselves, having a low involvement of e-government is perceived as a sign of weakness? Does the digital divide affect the transition process? How are the limiting factors for the advancement and development of the technological process? The analysis to answer these questions, we use the Digital Economic and Society Index, or DESI, as one of the main data sources we use, which also based on the EU 27 plus EK countries, the Gini coefficient, and the e-government survey UN 2020. The collection of all these different indicators come from different data collection methodologies, make their harmonization necessary. The calculation of the indicators of maximum and minimum score is a traditional method used to calculate the normalized score. About DESI, a weighing system for dimension and subdimension has been adopted. The same has been done with minor changes in this paper. The online service index, which measured the scope and quality of online services, has had a strong increase in countries whose per capita income is less than $30,000 per year. Countries such as Bulgaria, Cyprus, Czech Republic, Greece, Poland, Portugal, Romania, and Slovakia, with the two anomalies represented by Denmark and Luxembourg. Regarding the performance of connectivity, we note a positive leap for Bulgaria, Lithuania, Malta, and Romania. In this graph, we can see that net of the anomalies already highlighted in the previous figure, we had a considerable increase was Cyprus, followed by Romania, were detached with 9.38 points of increase. The current COVID pandemic has disrupted every paradigm, demonstrating the importance of digital resources for our economies and how digital skills are needed for our economies and societies. Digital skills, as shown in the graph, represent a sub-element of human capital. Therefore, having an internet connection is not enough. It must be matched with the appropriate skills to explore the digital society. In this figure, countries such as France, Ireland, and Sweden have achieved a significant increase in personal and non-personal digital skills, exploding a widespread process of computerization and reducing the phenomenon of the digital divide. A notable anomaly is Croatia, where its index dropped dramatically by 15 points. We can see, as can be seen from the graph above, those countries that have a strong increase in digital public services have had it regardless of net per capita income, without a strong distinction between low and high income. So there has been a sharp contraction by Croatia, Lithuania, and Sweden in digital public services. And we know that is not depend at all on net income per capita. As for the ICT usage, we have a strong increase for countries such as Cyprus, Czech Republic, Germany, Greece, Italy, Netherlands, Romania, and Slovakia.
Sorry for the interruption.
Slovenia.
You have only 2 minutes left.
Okay, I have finished. EU must play its part by taking the reins of the digital transition, coordinating and encouraging member states to adopt an e-government system that is interoperable for the benefit of all EU citizens. What we observe from the analysis carried out is the net income per capita has only been important in the online service index, digital skills and connectivity, while for digital public services and ICT usage, we have no direct correlation with net income per capita. Therefore, from the analysis, it is clear that the deployment of digital device, despite investment in infrastructure and the possibility of accessing this information, is still present. Technological innovation and organizational structure must go hand in hand in every production sector that faces the digitization processes. Only through a redefinition of the organizational structure in a digital perspective, it will be possible to take advantage of all the opportunities for improving and increasing the efficiency of the system as a whole that digital offers. The e-government offers many opportunities, but many challenges have yet to be solved. Thanks for your attention.
If anybody wants to ask the presenter. No? Okay. I'd like to ask. It's very important problem. We are talking about this problem many years. For 30 years, we created a lot of
Yes, it's a
criteria,
problem.
and of course, but I cannot tell you that this gap is changed.
No, for
changed.
our future
What do you
studies.
think about this? This gap will be everywhere.
Yeah, it's
do you think?
diffused in every country in Europe. More from some countries, a little less for especially in Northern Europe. Is this gap is very less, but we also work on this theme of digital divide, and it's still present. And no. It's not some governments are not so sensible to this problem, instead of other problem to digital transformation. Digital device is I think it's the real bottleneck for the transition, for the digital transition, instead in Europe or in all over the world.
Okay. And have you sent your results to any government or Europe government? Have you sent? Or it is only your paper and nobody in the government?
No, it's only our research, and not sure for for government application. We think have to invite some some legal representative for Italy to know this our paper, our work. But it's in this period in Italy we have election day, and the scenario is very confused, and we have to stop until 25 September for the election day.
Okay. Thank you very much. It's very interesting.
Thank you all.
This year, I with my very good friend from Italy, Massimiliano, published two very interesting paper about the connection human and artificial intelligence. I think that this paper will work,
Okay.
in your direction, and
Yeah,
to make the gap smaller.
maybe
Thank
we
you very
can
much. It's
we
very
can talk
important,
for each
very
other.
important, very important.
Excuse me, Alexander, just one more question, if I may allow, please. Can I ask a question? Yeah. It's just one question to Michelle. When you refer the concept e-government in Europe, do you think it's the same as the smart government, whether there's any difference? Is it like by any means just the digitization of processes offered by governments, or maybe it goes beyond like probably adopting AI? Because
Yes.
I think it's a bit confusing sometimes. We talk about e-government where it's actually smart solutions and the vice versa.
No, I think the distinguish from e-government to smart government or early digital government, fully for adaptation of AI in e-government processes. Some government processes have to use the human mind for take solution, for taking any answer of our lifeline problem. But the implementation of AI, I think, will be a help for take an advantage to answer our question, or be a boost for the transition in digital government, digital government, e-government, smart government.
Okay.
Some countries have to implement, had also to implement these artificial intelligence in e-government processes. Italy, not at all. But we hope in future have to boost ourselves
Okay,
in the
okay,
European
Michelle,
scenario.
thank you. The time is
Thank you
over.
all.
Thank you. Anisha.
Okay, thank you for your great presentation. So now we'll move further to our next paper. And the paper presenter is Ahmed Shuhaiber, and the paper title is Trust in Smart Homes, the Power of Social Influences and Perceived Risks. Dear presenter, you may please start your presentation.
All right, thank you. Would you all confirm that you can see my slides?
Yes, we can see it.
Okay, excellent. Thank you so much. Thank you, Alexander, Alicia, and everyone. And my name is Ahmed Shuhaiber. In my accent, it's Ahmed Shuhaiber, by the way. And I'm an assistant professor at Zayed University, UAE. And I collaborated this work with some of my senior students. We were interested in understanding trust in smart homes and what really can impact that trust, that consumer trust, in order to be adopted by users. So basically, I'm going to quickly introduce the concept smart home and then summarize the literature review. Talk about my quantitative methodology, share with you some findings, my research model tested, or probably our research model tested, and some limitations and future work. So basically, let's first distinguish the concept smart home than automated home. Automated home or digital home, the one that can be controlled by users remotely, like setting the AC of home from office. This is considered as an automated home. What we are looking for in smart homes, it is an IoT application. It's an Internet of Things application, where most, if not all, of the home appliances and devices can talk to each other directly without the interference of the user, of the home owner. So basically, it's like when I enter the home, okay, the TV turns on, it recognizes my face, and then the curtains go down if it is night, and then it turns on my coffee machine, and so on. So those machines start to talk to each other. And further, probably some appliances can talk to external entities, just like the smart fridge that can order some bananas if we are running low with the bananas from the grocery, so that it's ordered automatically and discounted from the credit card. This concept is becoming very popular, especially in UAE, especially in Dubai. And the UAE has an agreement, by the way, with that Chinese company, Xiaomi, for a big construction company called Emar, so that all its flats and apartments will be in 2025 fully smartly furnished. So this is it. It's an IoT-based environment. It's integrated with the lights, home securities, entertainment, door locks, almost every appearance in home. Why it is important? It's not only a new lifestyle of living, it could provide some really good solutions for elderly people, children with obesity, special needs, and so on. We can control the energy consumption as well. It provides that sort of data analytics, what sort of devices is using more energy than the others, what's turned on, what's turned off. It's also, while I'm reading some of the psychology aspects of technology, I've been into a concept called mental offloading, so that I don't really worry about whether I turned off the AC, or whether I turned off the TV while I'm traveling, or probably is maybe the door of the fridge is still open for some reason or not. It should be telling me in an alert if this is happening. So this is called mental offloading. I'm not anymore being involved or busy thinking of those things happening in my home. Probably might be even worse if it is like energy leaking or water leaking or or something else. So it's one direction, one way forward towards developing the smart cities in general and making our homes more sustainable. In a world grid, what's happening there with the smart homes? We can see that there's a high adoption rate in some areas in the world, including the North Americas, while it's a medium adoption rates in Europe and some parts of Asia. However, the other parts of the world is really yet to get examining and exploring those smart homes potentials and features. So what's happening with the literature? The previous studies tell us that in order users to use it, they need to trust it. So trust is one driver or enabler for that usage. It's really need to be studied, that trust. Trust, by the way, is a multifaceted concept, and it could be understood from different perspectives, just like psychology, sociology, and economy, by the way. So what we are trying to focus is what really the factors that can influence the user trust in smart homes. And unfortunately, very little is known about this. So we need to know what factors, in what direction, is it positive, is it negative, is it really significant or no? This is what we are trying to do. That's why we are aiming to empirically explore the factors, understanding how they are intercorrelated and in what direction. What we are trying to focus here more into the technology aspects of that application. So what are the perceived risks? What's the kinds of risks that can hinder that trust? And what's about the social influence, impact on that trust? Because especially here, I would say people here in the UAE, as in other Gulf areas, are heavily influenced by others' word of mouth and the subjective norm. So in quickly, we have just proposed those hypotheses. I'm going to revise them back, revisit them back with the model. Okay, so don't worry for now about the hypothesis. Our approach was quantitative. It was an online surveys. We need to understand the perception, what really influences user trust in smart homes. Questionnaire with 16 items, 16 questions, all with 5-point Likert scale. It was convenient sampling with some conditions that those respondents should be aware of smart homes in UAE. They must be residents so that they are aware about the concept, and with the age range of from 18 to 65. We shared this survey through social networks, Twitter, Facebook, LinkedIn, and Instagram. We collected 158 usable responses, and then the analysis was through the Smart PLS software for multiple regression. And very quick, our stat say that the item loading was really okay. All of them exceed the 0.7, most of them 0.7. By the way, the threshold and most of the resources are 0.5, and we have it, all of them is above the 0.7 threshold. And then we tested each construct separately by measuring the reliability and the validity. So all found reliable by using the Cronbach alpha measures. All of them are above the 0.7 measure. All of the AVE scores, this is for the validity, are above the 0.5 cutoff point. So all our constructs, all our variables were found valid and reliable. And we were expecting this, by the way, because most of the constructs are there found in other literature review, but we just made a new relationship and trying to understand their influence on trust. So basically, I can go and visit the model. Here's my model, our model, by the way. We propose that the social influence can directly influence trust. Security risk, perceived security risks, can also directly, significantly influence trust. Privacy risk, about the consuming patterns and behavior that could be shared with external parties, also has a positive, really big positive on trust, and also the financial risk. Definitely those are in minus because they have a negative impact on trust. So what's really interesting is that, as you can see from the beta efficiency, the path that has the hugest impact on trust is the security risk, not the privacy, not the financial. So it seems that people are more aware that there are some security risks that could be hinder their trust, including hacking, cracking, and attacks, penetrations, and so on. Some others also believe that they can be losing some money in smart homes, maybe because those smart appliances and devices are costly. Maybe it's about the cost of installation. So they need to look after those devices. There might be a financial risk, whether there's a device that's malfunctioning or some problems with those appliances. Very, very, very little actually who have just expressed their privacy risk about sharing information, sharing their personal details with others while they are using those smartphones. However, we can see also that the social influence has a big, huge positive impact on trust. People here, as in other Gulf region, tend to share news and hear from others. So this is really also important. I'll get back to you if you have any question regarding the stat. But for now, definitely as any quantitative-based research, it's associated with some limitations, including the instrument itself. It might be biased, or probably the construct we are using, however, all borrowed from the IoT just to reduce the bias to the minimum. And we checked with the survey items by using a panel for academics to check the face validity and all other wordings of the items. Our future work with the students, as we had a meeting recently, we thought maybe we can extend our research model, including the cultural factors. And this is what makes probably the trust in UAE is different than the trust in London, or maybe in Europe, or maybe in the US. So what sort of cultural dimensions suggested by Hofstede could be really adopted? This is
1 minute, 1 minute.
Sure, I'm about to finish. And maybe testing the model, maybe in other contexts, so that maybe other researchers or scholars can have the same model, but testing it in other contexts and see whether it generates the same results or not. This is pretty much a quick visit about our research about trust in smart homes, and more than happy to hear from you any questions.
Okay, very interesting presentation. I'd like to ask you the question which I have been asking for 20 years, but I cannot get an answer. This smart home has to, the system of ruling smart home has to include the artificial intelligence component. And this component can give us the advice or recommendation. But we cannot trust this system if the artificial intelligence system, because the artificial intelligence cannot give us an explanation of its recommendation. What do you think about it?
Yeah, thank you, Alexander.
How can I trust the recommendation of the system? Shortly. It's very. Yeah. I think that we understood.
You know, we have different models of trust when it comes to technology, and the AI probably made it even harder to trust in those machines. However, dealing with those robots and smart intelligent agents and machines, it's now becoming more easier. And the funny thing is that regardless we are trusting this or not, we are using it, by the way. So although a matter of trust is really important, how can we trust AI? It's the thing that, do we really trust the algorithms behind those robotics and machines? This thing. The other thing is that what really makes us try to trust is some constructs like triability. Why not to try it? Why try not to at least do integration with
Thank you very much. Now we are working on this problem with 2 professors from Italy and 1 professor from USA, and we cannot get an answer on this question.
Yeah.
But I think that will be okay. Anisha, the next you will give the next.
Yes.
Okay, thank you.
and the next will be me. The next will be
Okay,
me.
okay.
The
Yes,
next
we'll.
presentation is more interesting than this one. Thank you.
So now we'll thank you for your presentation, and now we'll move further.
It's me the same, by the way. Yeah,
Yes.
it's me. It's another research
Okay.
by
Okay. Yes.
another group of senior project.
Okay, you can continue.
Sure. Let me just. So, welcome, professors and colleagues. It's me again. And here's another group of mine working on another project, senior project. They were thinking of how can really achieve a sustainable community. How can we make it really green? How can we part of contributing to that green economy? And then it was the idea of e-barter system, e-bartering system. So those are my students, Hiyam, May, and Meitha, with the same department at the same university in UAE. So let's first, by the way, this is another methodology. This is another thing. It's not a quantitative, it's a development, IT development project. Let me first introduce the e-bartering business model. What do we mean by it? And what previous research work are there, our methodology, and then future work. So basically, how many appliances and devices, dumb thing, it's just there in our homes. We don't need it. It's just gathering dust. And it's almost valueless to us, but it might be valuable to others. There are definitely many items in our homes we don't need, okay? However, we need, on the other hand, we need other items. So let's barter it, let's exchange it with others freely. So this environment, e-environment, this electronic platform is basically to e-bartering among residents in one country, UAE. It's an online trading system where we don't need to pay money. It's just exchanging items. What Alexander may not need at his home, he would post it on the website. What Ahmed might need, maybe Alexander's item, I will contact Alexander, I'll get that item, and the vice versa. Maybe Alexander will talk me whether you have that table, whether you have that coffee table or something, maybe I have it so we can exchange it. This is the idea behind our website, the e-bartering system. It offers bartering for all the 7 Emirates in the UAE, including Dubai. It could allow any goods or services. It's really part of that feeling of being one of the social member of that sustainable community, where anyone can exchange anything. So what benefits? Increasing communities' cohesion. And I think we need this in the online, within the online digital era. It also increased the items recycling instead of just getting rid of this. It's the public benefit. It's the hope for the poor. It's really green and sustainable. And it makes also that community more in harmony while we are there changing products and services. So we don't need to have big money in order to get some important devices or appliances in our homes. Is there really good previous work about this? The answer is no, unfortunately. We found only 4 cases, one by Yemen University in Malaysia, where they developed that mobile application, the other one in Cambridge University, and that website actually were developed for the people of UK. Also, a research team in Istanbul, Turkey, have worked on a similar mobile application, but it's still in its early stages. So the point of the literature, it's about, let's bring this old concept, bartering, but with a new technology flavor. So we need to barter things, okay? but through a platform which makes it really easy. So it reduces the disposals. It's very easy to use. It can create wealth as well. And the good thing is that maybe Alexander from a different background, that I wish maybe he has some books to share for free. And I'm from a different background. I also have some books shared for free. So maybe we can also exchange those books. It's not necessary those tables or chairs or maybe electronic devices. It could be also a cultural thing where people really live in more cohesion than others, especially that UAE is really multicultural society. So what methodology we consider to develop that website? It's a website, by the way, and then it's an extended through a mobile application. We follow the SDLC, System Development Lifecycle. We planned for the system, analyzing and modeling, and then move to the design. By the way, we are now stuck with the implementation. The students are working on the coding for now, okay? And then it's about the technical support. But I'm mostly welcome. I wish you can, whatever suggestions you suggest for me and my team for the design probably of an idea features for that system. And very quick, the system is feasible. It might be costing around 100,000 dirhams in terms of fully hardware, software, and everything, okay? By the way, $1 equals to 3.6 UAE dirhams, okay? So it's like divided by 3 to get that US dollar. I'm sorry because of the small font, guys, but you definitely got all the details in the paper, okay? These are the cost-benefit analysis for the tangible and intangible benefits and for the running and one-time costs. We mainly focused on what requirements we need in this system. And then we have those user requirements. It should be easy to use, smooth bartering experience, no need for cash, no need for money, so no need for payments for now, okay? There are points and rewards to get them encouraged to share. System requirements, they are functional and non-functional. Input-output process. I don't think we have enough time to discuss those. However, I think the idea is clear. Maybe again, you can refer to the research paper as well. We have also non-functional requirements regarding the security and the performance and the control of that website. So we considered all the requirements of what we need in this website. As part of our modeling, we started with a context diagram. We have basically 4 entities: user, contract, item, and IT support. We need them all in terms of input, output. And then we had this level 0 data flow diagram, starting from registering, login, search for items, start exchange. And this is it, get the contract signed, because it must be legally approved. And then this is our ER diagram, entity relationship diagram, for modeling the databases. We need to store data about the items, shopping carts, user, contract, IT support, and exchange processes. This is the decision tree. And again, it's full of details, okay? They started with the design. You need to, by sign up, to put your details, get identified by the system through your national ID, and then you enter that website. That is Ebartering. It describes the idea to all users, okay? And then it shows what product people have shared who wish to exchange for free and what they are asking for, by the way. So, and you can, as a user, upload your own. I know it's very basic design, that's why they're still working on it. And they put information. And by the way, it's not only for exchanging products, could be exchanging services. Like, for example, Alexander can share with me, exchange with me his books, and I can teach him how to play guitar, for example. And this is also fine with this. It's a product against service, which is also allowed. So you can book a service, you can see what other products you can exchange for it. It's the time of implementation with the team. It's one of my very recent senior projects, by the way. They are still involved with the coding, testing, doing yet to make the installation, so that they are now with the coding, working on the SQL as well with the databases. So more than welcome to hear from you, whether you like the idea, whether you wish to get improved in any way. Your suggestion is really, really deeply appreciated. And thank you.
Okay, thank you very much. It's for me, it's very interesting idea. I think that I have been thinking about this problem all my life, because I know that many years ago, humanity didn't have money, but 5,000 ago, people created money and writing. And this invention made people very strong. And you suggest to work without money. I think that in 10,000 years in the future, we will live without money. But now, how can you live without? How many people can live without money? I don't think that it's a very large set. What do you think? How many people live without money?
I agree with you.
In one set, in one net. Okay.
I agree with you, Alexander. But however, if I need a table, I'll definitely search for one of the websites or probably one of the shops and get myself a table. However, it would be in its original price. It would be pricey. Even if I have money, by the way, I will search whether someone is doesn't want his chair, by the way, or table or so, and he is willing to share it for free, exchange it, instead of like getting another something else for my items for free. So it's the process of bartering. You give me something, I give you something instead. It's not necessary to make it sure equally when it comes to monetary value, but I mean, if like, for example, you have a mobile, if I have a mobile and I can give it
this I understood this, but we made an experiment. We made this experiment 25 years ago with our government, but then we refused because every group of people began to create money.
Yes,
paper, order, something thing, electronic equivalent, cryptography, something. They began to create, and the issue become a political issue, issue, because the society began to be divided.
It might have definitely some restrictions and challenges, I would say. However, it's really a chance for the poor. It's really a chance for people to share some stuff that they don't need with others who really need it. And probably in some stage, if I'm going to exchange with you a mobile device with a book, then maybe I can, you can pay me maybe $50 so that we can make this transaction. So it's based on an agreement between you and I. I'm not saying this is 100% payless or cashless, but it may be to some extent it is with very minimum monetary transaction. Where can I get my any item I need? Okay, and you can get the items you need, and we get to know each other's, and probably this our second generation, by the way, to make it as a social media platform. So it's just like Facebook or Instagram. So we are sharing this. We need to introduce to other people. Why not to know you, so that I know people in the other towers, because I don't know all of them. So it's part of getting this all together again. This is part of the idea.
Okay, very interesting. If you don't, I'd like to read your. I will read your paper. Perhaps
Thank you. Thank you so much.
Okay, because I have got some papers on this thing.
Yeah, okay. Please also let me know by email. I'll be more than happy.
Yes, I will give you my. Anisha, what's the next?
Yes, sir. Okay. So we are done with all the papers. I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version and the previous 5th version of the conference. We will be happy to have you in the 7th version in 2023. So all the presenters would be getting their digital certificates through email within 2 to 3 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of WS4. I also like to thank our session chair for chairing this session. Here is a token of appreciation on the team of WS4 and on behalf of the Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Okay. Thank you. Thank you, everybody. I congratulate everybody. It's a good opportunity to get very interesting information. The main words that is spinning in my mind is the word from one disruption ideas. A lot of disruption ideas. Thank you very much. I congratulate you with very great success of everybody. Thank you very much.
Thank you so much, sir. Okay, so as we have come to the end of this session, I would request you all to please switch on your cameras to take a quick snapshot of this virtual conference. Okay, thank you so much. Take care and stay safe. Goodbye.
Thank you. Thank you, everyone.
Thank you.
Thank you.
For everything. Anita, thank you.